Question leads me to understand bias theorem is this. When you look at the question, you can see that the question is fairly simple and you can do it by intuitively, but if you try to understand what's going on beneath it, you can understand intrinsically so that you can do and apply what I do here to every kind of question. Let's see what the question is. Consider this game. Bob is selecting one of two coins from a bag, and one coin is standard coin and second coin is a fair-sided, unfair coin, which is with two heads. What is the probability of choosing unfair coin if we know the outcome is head? What I do, just taking a graph line. I'm here and I'm choosing a coin. This could be unfair coin or fair coin, and I'm writing the probabilities. Choosing the coin. And then I'm flipping the coin. For unfair coin, there's two likely outcomes, which is both heads. You can write these as one. It will not matter, but if you separate for this question like this, you can apply these to another question's formats. And for fair coin, there is two outcomes as well, one head and one tail. Then we try to understand the question verbally. Let's see what is our A and B. A is choosing unfair coin and B is probability of heads. Why is that? Because in the end of the question, what asks us, what is the probability that we are trying to find is A, and that is what is the probability that unfair coin will be chosen. If we know that the outcome is head and the given, which this sign name is given, B will be the probability of heads. After that, we are just writing the formula. P, a probability of choosing unfair given heads, is equal to the probability of choosing unfair and getting heads at the same time divided by probability of getting heads. Probability of getting heads and the unfair coin is signed with the blue dots, which I know it is the unfair coin and I know it is the heads. Since they are both heads, we are just writing the outcomes. You need to remember that when you follow a path, you are taking a product of the probabilities. If this one was 0.6 and this one was 0.4, then you need to take the product of 0.6 times 0.5. And we will do the same thing to this one. When we are following this path, we are writing the probabilities products. And you are taking the sum of every category otherwise. Let's take a look. 0.5, which is this, times which is 0.5, which is this, and 0.5 times 0.5, which is this. And we are taking the sum of them. For convention, I just write it like this. And what is the probability of getting heads? I know that if I follow this path, this path, this path, I will get head, and if I follow this path, I will get tails. Since I know that is not the case, I can just eliminate that and not look at the probabilities of that. And to find all of the probabilities that I'm getting heads, I need to follow every solution ends up with heads, which is this path, which I write here, this path, which I write in the second one, this path, which I write in the third one. And the rest is the calculation.